So these questions are going to ask you several parts a lot of times. All right, and this is how they would look on the Regents exam or your own exam, your assessment at the end of the unit. So it says there's a model, it gives you the model, it doesn't make you write it. It says T stands for the number of years since 1980. So right away we have one of these things. In that decade, what was the annual growth rate of Indonesia's population? All right, well, the growth rate is inside of here. All right, and it's whatever the difference is from 1. So it'd be 1 minus let's not do it that way. So get a negative 1.021 minus 1, which is going to give me 0.021 as a percent is 2.1%. All right, so we have to be careful. If it asks us for the rate, we have to make sure we find the difference between 1 and the number inside of those parentheses. All right, what was the population in 1980? That's the original population, which is that A number right there. So 148.7 million. We also have to make sure that we read the problem in terms of what units it's in, because the numbers are normally going to be small looking numbers, but they're usually going to be in millions or thousands or hundreds or something. All right, so we have to take a look at that and make sure we're labeling things correctly. What was the population of Indonesia in 1987? All right, so 1987, we do not enter 1987 into the formula. 1987 minus 1980 is 7. All right, so 7 is going to be my X or my T or my N or whatever the heck I want to call it. So it's going to be 148.7 times 1.021 to the 7th. All right, so I've got that. So I can go in here, 148.7 times 1.021 to the 7th gives me 171.985. Doesn't tell you what to round to. So 171.985, ... Okay. And then for E, oh, there is no E. Sorry. Oh, no, hang on. That was C. It's early in the morning here today. Okay. And then D says, about how long will it take for the population to reach 170 million? Well, that's 171, so it's going to be slightly less than 7 years. All right, I could probably even say 7 and be pretty close. So it's 170 equals 148.7 times 1.021 to the X. Clearly, it's going to be a logarithm problem because the X is in the exponent. I have to isolate the exponential term, so I need to divide this by 148.7. All right, and I'm going to get, 170 divided by 148.7. 1.143 equals 1.021 to the X. Change it to a logarithm. Log base 1.021, 1.143, ... equals X. Let's make that an actual 1 instead of a squiggled line. The logarithm part goes in the calculator. Alpha, window, enter. 1.021 goes down there. That's not what I want. Sorry. Alpha, window, 5. Okay, there we go. And then I go into the parentheses, go up, hit enter, hit enter. 6.441. 6.441. So about 6.4, let's not. So about 6.5 years. The reason I'm going to round up is because at 6.4, if I put it in there, I would not have 170. All right, at 6.5, I would have 170. So I want to make sure that I round up in most of these cases. We have to think about it. If it says I need to reach 170, if I round down, I'm not going to actually get to 170. So we do have to think a little bit more carefully about the rounding there. You know, I caught myself, rounding is a very minor problem. But again, if we're trying to get the highest possible score we can on something, we want to make sure that we're paying attention to things like that.